Okay, hello and welcome back everyone. Today I'm Kevin from KevinMC, and this is my printer. So today I'm gonna be talking to you about how I've been using this thing and how I've been getting this thing to do quite nice prints basically, yeah. So let me go and show you this printer itself. So this is basically an Ender 3 V2. This thing used to be stock, but it's not stock anymore right now, yeah, as you can probably tell. So this thing is in an enclosure because I print only ABS. This is some Esun Max YZT Bastard ABS Plus, which is basically the only ABS I've tried so far. I used to use the old Esun ABS, which is somewhere here, I believe, not here. Oh, this thing. Okay. See, this is what I used to use, but they don't sell this stuff now, so I'm only using this Max YZT stuff because they don't sell this thing anymore, yeah? The OG green Esun. So, okay, next off, let me go take this enclosure off, because this thing is important if you're printing, it's not important if you're not printing. This thing can go up to 45 degrees Celsius if you're printing like over half an hour, so this thing has been quite interesting in how it works, yeah, because as you can see, there's this like huge gap over here, yeah? Okay, I believe you can see the gap. I'm filming this thing on a 28mm f1.8. It's the Canon EOS M1, so it's gonna be quite shallow at this depth of field because I'm using this on a Nikon body, my Nikon Z6, and it does not have aperture control. I prefer to film this thing in f4, but now I'm in f1.8. So yeah, so this thing I made from cardboard, tape, and some newspaper and some plastic. So this thing is not a perfect enclosure. I believe I can get 50 degrees Celsius if I actually want to like seal this thing off even better, yeah. A good idea if you're making this stuff is to actually put magnets. So put one on the other side of this thing, of the cardboard, like over here, yeah, and then put one magnet in front like this, yeah, and that way you can actually seal the plastic itself, see. But instead I'm using tape because you do not have any magnets. This stuff is gonna stick on this tape over here, and you can use the tape up to a few hundred times, I believe, yeah. So let me go put this thing away and lift the enclosure off, yeah. Okay. And this way you can actually see my printer itself outside of its enclosure. So this is the stock Ender bed, the glass one that you get on the Ender 3 V2. If you're using the Ender 3 V1, I believe you actually want to change the glass, the bed, because I think you get some flexible one, yeah. So that's gonna burn off if you're doing this 110 degrees Celsius printing every single time you print, and that's basically a consumable, yeah, once you do that. So it's not a very good thing. Next, you also have this, which is a direct drive extruder. I used to use the Bowden one up to like a few months ago, because if you're using Bowden, yeah, what will happen is that the retractions and stuff like that will actually make time a bit slower, like printing time a bit slower, and also the filament will sometimes get stuck onto the what you call this thing, like the arm thing over here, yeah, basically, and that's not a good thing because then your prints will fail. And also this thing, this aluminum thing, yeah, is here because the original one cracked. Let's try over here, yeah. Okay, and the original one is here, yeah. This thing I've cracked over here. So then I moved over to this thing over here, yeah, which is the like generic metal what call this thing, extruder assembly thingy. This thing was shit, yeah, out of the box, because obviously, as you can see, the filament has to go in here, and if you're printing ABS, it's hot as hell, yeah. So even in the Bowden setup right here, it would always get hot as hell basically, and like get the filament stuck over here. So then in the end, I polished the entrance part over here, yeah, for the filament, and also put a bit of Bowden tube over here, yeah, a little bit of PTFE liner, and stuck it over here. and that way I actually have less friction than I used to have, and now it prints perfectly fine. Next, what else do you have? I have the original bed springs. People usually change these things out, yeah, but for me I kept the original ones because if you do change the springs, I find that if your print has a zit or some blob basically, yeah, some prints do not come out perfectly. Like, see, this thing has no zits here. Yeah, see, this thing. If I focus very close up, I believe you can see there's a zit over there. See? Right there. Okay, you can easily kick that thing off with your fingernail after you print the object itself. But if you do not have soft bed springs, what happens is that your bed is gonna be stiff as hell, and if your gantry is stiff as hell also, then what's gonna happen is the nozzle is gonna hit the zit and basically impact the part. If the part melts fast enough, like say PLA, it'll be fine. But if you have what you call this thing? Let me go put my keyboards over there so I can actually sit down. Okay, so if you're printing something like ABS, I print at 242 degrees Celsius, sometimes 240. So if you're printing at an ABS, if the part's big enough, the part will actually cool down, yeah. Say you're printing this thing. Let me go show you, yeah. Printing this thing. Say you're... Wait, what the hell is this? There you go, okay. So, say you are printing this side. Then, this thing has to sit over here, yeah. Then you print the whole thing, and you come back over this side. This thing's gonna be cold enough that if the nozzle hits it, it's gonna wanna jump. Or push the part itself. If it jumps, because the bed can actually be pressed down by the soft bed springs, you're gonna be fine. But if you actually have the part get knocked off, that's a problem. Because if you get your part knocked off, then what happens is basically your part will not be stuck on the bed anymore, and you'll have a spaghetti mess basically, yeah, which is not what you want. So the next thing I've done is also I've moved over to the cheap ass all metal hot end I have right here, yeah, which is inside this, not even sure what like this thing is called, yeah. I think it's the mini me thingy. So you're using the stock fan, and you're basically directing air from both sides, both from the right and from the left, which is a good thing. But for my setup, it's not really needed, yeah. So the original fan is somewhere in this ender box right here, yeah, which is not a very good place to put it, but yeah. So the original fan housing is quite heavy, and also only hits from the right side, I believe, yeah, the fan. So what I did was I changed to this thing. So in the rare occasion that I print PLA, this stuff is PLA right here, yeah. In that rare occurrence that I print PLA, I will get better prints. Because what used to happen is that once I have to print, say you're printing this object, yeah, with threads like this, yeah, see? These are quite fine threads right here. So, say you're printing this thing like this, see? Okay? What happens is that this side's gonna be good as hell, then this side's gonna be a blobby, disgusting mess in PLA, because of the fact that you only have one side getting the fan and one side's not getting fan at all. So what I did was do this, and I mean do the fan mod, yeah, and that pretty much solved that problem. And I'm not sure if I have anything else that I've done, yeah. I've adjusted the acceleration settings on my slicer, so you actually print way faster than you usually do on this thing. And yeah, that's pretty much it. Because with this direct drive being this nice, yeah, see, you can see the filament line, it's not going anywhere basically, it's only staying like, see, not very, it's not like the original one where it goes from here down here and it bends right here and it goes back into the hot end. That is not very efficient and not very nice for the filament itself, yeah, because your filament might break in the process. So this is what I've done, and yeah, it's not very much. Let me next show you what's in the slicer. Yeah, so let me go and walk to the slicer. Sorry for my house being a mess. Okay, now welcome to my workshop. Okay, let's open the computer up, and now let us see. Wait for a while. Yeah, I want to open a file. Say 3D files. Let's open one of these projects. Let's see, what's this Bolger Academy? Let's say I want to open up Mount Shim. Let's say you want to open this file. I believe this thing is for the what you call this thing? For the why is this thing showing some error? I'm not sure, but yeah. So my camera's throwing me an error for some reason, but let's just let that be. Yeah. So this should be the file that I showed you just now, the result of printing this mess. Oh, it's not that, yeah, but so what? So in the slicer you can actually set your acceleration. See? And I use these settings right here, whereas the original ones would be 500 in all of these things. So that's way faster, and print resolution and outcome has actually become quite a lot better, I'd say. So let me go find my comparison prints. So these are all Canon FD adapters to Leica M. Okay, as you can see, you have one FD right here. Okay, so try guessing which one was printed in the fast setting. The insides, as you can see, yeah, are a bit different because this thing you didn't have to like scrape it with a cutter. This thing you needed to scrape it because of some odd reason, yeah. But yeah, so as you can see, these are actually quite similar in finish. For the bottom layer, let me go check my screen, try focusing. That's your bottom layer right there. Okay, let me go flip this thing up like this. This thing I believe I turned on ironing. This thing I did not. You can see the little flaps, or like the bayonet basically. Okay. That's a seam on each of them. Okay, and for the FD writing. Okay, so which one is printed in the quick setting, which one was not? The answer is this was printed in the standard setting. This thing was printed fast, and honestly you can't even see the difference then. If anything, the FD writing on this one's actually quite a lot better than this one, because this thing had a lot of like overhang stuff like that, yeah. I mean the writings were overhanging by a bit, and this thing just drooped down a lot, yeah. Let me go show you. See? You can see how that thing droops a lot, yeah? The F, see? Then this thing, the F does not droop a lot, see? So, yeah, overall I actually like this printer quite a lot. You can print at warp speed basically with this thing, and still have it produce quite nice prints, even better than stock. So yeah, thank you for watching everyone. Hopefully you've seen my printer and like got some inspiration from my printer basically. on how you actually want to continue your printer itself. Like if you want to use it as is or if you want to upgrade. Because for me, upgrading that thing, I didn't spend a lot. I spent less than $10 overall. So yeah, it's not very expensive to make an Energy V2 work a lot better, a lot faster, and overall become a better printer. What you could do from my setup, guys, basically get a dual gear setup for your hot end, I mean for your extruder, that would enable you to use like flexible stuff, say TPU, and also you could also do this, which is you could make a heated enclosure, because that would also make your make your temperatures go up basically. Yeah, even these things are quite strong. Let me go demonstrate. Yeah, so this thing's the one I'm not gonna use, this is the one I'm gonna use. Let me go demonstrate by putting this thing on the floor. That's FD adapter, and then let's take this hard drive, which is not used anymore. This thing is a broken one I use for soldering. Then let me go step on this thing here. It's not gonna break, see? 1 foot on, 1 foot off. See? It didn't break. Because it's new. So, and this is not even a thick part, see? It's because it's new. Shit. Okay. See? So ABS is strong enough if you print it at like 45 degrees Celsius. If you want it to be stronger, you can actually print it at like 50 or 60 degrees, like a Voron, but then you can actually do it by putting more insulation into the printer itself. Let me go bring you back there, yeah, to the printer itself. So here's the enclosure I have. As you can see, I only use one layer of newspaper here and some very thin plastic. See, it's very thin, basically like plastic bag type of thin, yeah. So it's not very good insulating material, and you could get a lot of bare materials to insulate your printer with, yeah. Say acrylic and stuff like that, or glass. Those are very nice insulators which will give you better results than using plastic. But this thing is basically free, yeah. This thing was like from like some garbage I had at home, because as you can see I have a lot of garbage right here, yeah. So it's like random bits of plastic right there, a lot of keyboards right here. These things are all keyboards inside there, some leather material, more plastic, more keyboards, stuff like that, yeah. So this thing was free to me. This thing cost me not very much. So if you want to print better on an Energy V2, that's what you can do. I've heard of people actually changing the Z-axis by making it dual Z. Mine is still a single Z, as you can see right here. These cables have been extended because I did the direct drive mod, yeah, which needs you to have longer cables right there. See? But overall, nothing has really changed that much. It's mostly still stock, and I plan to keep it this way. I'm not gonna be installing clipper and stuff like that onto this thing, because everything still works as fine as I intended to work, yeah. If I want stuff like CF printing and stuff like that, I might go change nozzles, change my enclosure obviously. But yeah, everything else works fine right now, so I do not find the point in changing this thing up more than it needs to be. So thank you for watching. Hopefully you have a good day, stay safe, and hopefully you also get your printer to work quite well, yeah. Because if you have a well set up printer, you can actually do a lot of stuff easily, unlike on an untuned machine, which is not gonna give you a lot of fine prints, and instead you're gonna get a lot of these things, yeah, which are basically failed prints. These things are not failed, yeah. These things are like mostly shit prints where your nozzle gets like clogged and stuff like that. This thing still has a quite new nozzle, It's only gone like a half kilo of filament through the nozzle, so it's basically new, yeah, this nozzle there. So yeah, thank you for watching. Have a nice day, goodbye.